So I'm looking at SEC 2019 Leaving Cert Higher Level Maths Paper 1 Question 7. I'm going to either let you pause the video and have a read of that, or I presume you're here because you're trying the question and are a little bit stuck. So jumping into the question then, it says complete the table below to show the length of the line segment removed at each step. So how big is this section that is removed? It is 1/3 of the full line. Now what's now removed? What's the new bits that are removed? The new bit is only those two sections. They're the new bits. So if this length is 1/9, this is 1/9 and 1/9. So we're saying only 2/9 are newly removed. What about the next one? What about what's newly removed? I can leave those there. What's newly removed? This is newly removed, newly removed, newly removed, and newly removed. So if this section is 1/27th, then there are 4 27ths that are newly removed. We can spot then that we're getting a geometric series. We're multiplying by 2/3 each time. 1 by 2. Remember, how do you multiply fractions? It's top by top, bottom by bottom. So you're multiplying by 2/3 each time, and you're building towards a geometric series. It is a geometric series, and that's why you can finish it off. Find the total length of all the line segments removed. So everything removed from the initial line segment of length 1 unit after a finite number, so not an infinite, a finite number of steps. So they want us to find, what do we get when we add up 1/3, 2/9, 4 27ths, 8 81sts, and so on. So as I said before, we're getting a geometric series. We're finding T1 is 1/3 and T2 is 2/9. Our common ratio can be found by going T2 over T1, which gives us or being 2/3, as I said already. So or is 2/3. Then we're using the sum of a finite geometric series from your log tables. It's also, it's in your log tables. So it's in your log tables. Fill everything in. We know A is the first term, or is the common ratio. Okay, it gets a little bit tricky then on the bottom line. 1 minus 2/3 is 1/3. That's fine. But how did I go from here to here? So this 1/3, I'm dividing by a fraction. Well, if I'm dividing by a fraction, I can invert the fraction and change to multiply. You might have learned it as flip the second and multiply. And then 1/3 times 3. 1/3 times 3/1 is just going to be 1. So you're just going to be left with 1 minus 2/3 to the power of n as your Sn. That's the full length that is removed. And then find the total length removed from the initial line segment after an infinite number of steps. Okay, so now we're not using our Sn. We're now using S infinity. Now using S infinity, same A and same or. And what you find is that S infinity will simplify down to 1, because you're getting 1/3 over 1/3 here. 1/3 over 1/3, anything divided by itself is 1. So if we kept going on forever and ever and ever and ever and ever and ever and ever, we'd find that the entire line segment gets removed. Okay, next question then. Complete the table below to identify the endpoints labelled in the diagram. So I want to identify A, B, C, D, E, and F. So kind of what I've talked about already. If this is 1/3, this would be 2/3. So A is 2/3. What about B? 1/9, 2/9, 3/9, 4/9, 5/9, 6/9, 7/9, 8/9. So C is 7/9. D is 8/9. 1/27, 2/27, 3/27, 4/27, 5/27, 6/27, 7/27. So E is 7/27. And just to speed things up, 2/3 in 27ths. 2/3 in 27ths is 18/27. So this is 18/27. This is 19/27. 20 27ths, 21 27ths, 22, 23, 24, 25 27ths. So F is 25 27ths. Really nice question. Just filling in the table, going back and counting. Little bit of a curious question. Give a reason why 1/3 minus 1/9 plus 1 1/27th minus 1 1/80 minus 1/81st is in the Cantor set. Well, if you actually go and add this all up, you get 20 over 81. And it's worth checking, is 20 over 81 going to be part of the Cantor set? Yes, it would be on the Cantor set. This is a point on the Cantor set. And last but not least, another little bit of a strange question because it's a geometric series, but we wouldn't be used to geometric series. Wouldn't be used to is not fair. It's not very common that we'll get a question where the common ratio or is a minus number. So anytime you see that it goes from minus to plus to minus to plus to minus to plus, we know it's going to be multiplying by a minus because it alternates between plus and minus. Because plus by minus is minus, minus by minus is plus, plus by minus is minus, minus by plus is plus, and it keeps flipping back and forward. So we know our first term is going to be A, and our common ratio then, again, you can go to get the common ratio, T2 divided by T1, so or is equal to minus 1/9 divided by 1/3, and you'd get minus 1/3. Okay, it says it is it's an infinite series because it goes on for forever. The limit of this series is a point on the Cantor set. Find this point. So you just need to apply the sum to infinity of a geometric series, knowing that that's there, and we're getting 1/4. Bit of a weird question. I will show you the marking scheme. It is not the nicest of questions. They gift an awful lot of marks to you, 10 marks to begin with. Really, really nice. 5 marks, and then I think there's a lot of 5 marks if I remember correctly. Yeah, another 5 marks. A part 3, B part 1. B part with 10 marks, super easy 10 marks as I said. 5 marks for just adding it out. Look, 20 over 81 is a point on the Cantor set. A bit of a silly question to be honest. And then the last question, 10 marks again for just using the sum of a infinite geometric series. So some easy marks there, but it's not a very accessible question, I think. I just think the phrasing of it is a little bit off maybe. But hopefully you found the video useful anyways.